So this question says triangle FGH is similar to triangle JKL, where angle F corresponds to angle J, and angles G and K are right angles. So to start off with, I'm going to use the strategy plug-in picture, which basically says anytime a question describes something that can be drawn, I'm going to decide to go ahead and draw it. So I'm going to draw right triangle FGH, starting with F here, G at the right angle, like the question said, so then H is here. But I'm also going to have JKL in the same order, J and K and L. We're also told that sine, or the next part of the sentence says, if sine of F is 308 over 317, well, that means that this side here would be 308, and that the hypotenuse here would be 317. I know that because here's where angle F is, and based upon SOHCAHTOA, the SOH portion of SOHCAHTOA, we know that the sine of an angle is equal to the opposite side of that angle over the hypotenuse. So that's how I know where 308 and 317 go. What is the value of the sine of J? Okay, so we know that these two triangles are similar. What does it mean for two triangles to be similar? That means that the angles are congruent. So that means angle F and angle J are the same. Angle K and G are obviously the same. They're both 90 degrees. And then also angles H and L are the same. What else do we know when we're told two triangles are similar? Also, we know that their side lengths are proportional, right? So either they are a multiple of, in fact, they're always a multiple. It's just determined by if it's a multiple of a whole number or by a fraction, right? So KL could either be like 308 times some whole number, 308 times 2, times 3, times 4, or it could be 308 times a half or times a third. It could be smaller than 308, but still by a multiple of a fraction. So they're proportional in that way. Now, how does this help me? Well, it helps me because I can then label KL, for instance, as 308x, where that x represents this unknown value that I'm going to multiply by 308 and represents the fact that this is proportional to that. And same thing here with my hypotenuse. It's like a 317x. So the question goes on to say, what is the value of sine of J? Well, the sine of J is, again, like we said for sine, it's the opposite over the hypotenuse. The opposite of angle J is 308x. The hypotenuse for this right triangle is 317x. There's really no need to keep those x's there. They cross out anyway, so it doesn't really matter. And therefore, the sine of J is just the same as what we had for the sine of F. So 308, I'll use green here, 308 over 17. So our answer is choice B for this question.